dear students. In this session, I am going to explain about relations. So first of all, we have to know the definition of relation, right? So the definition is a relation R from a non-empty set A to a non-empty set B is a subset of the Cartesian product A cross B. So the relation is denoted by capital letter R. So the relation means a relation R from a non-empty set A to a non-empty set B is a subset of Cartesian product of what? A cross B. In our last session we already know what is Cartesian product, right? So relation, it is denoted by capital letter R, and a relation R from a non-empty set A to a non-empty set B. So for this relation we have two sets and both the set must be what? Non-empty, and this relation is a subset of Cartesian product of two sets, that is A cross B. Understand? We want two sets for relation two non-empty set A and B, and a relation from a non-empty set A to a non-empty set B is a subset of the Cartesian product of A cross B. Okay, the subset is derived by describing a relationship between the first element and the second element of the ordered pair A cross B. If we get a relation, for example A comma B, and this ordered pair gives this relationship between the first element and the second element. So relation means it is a subset of Cartesian product and gives relationship between the first element and the second element of the ordered pair. Understand? So the next definition is and also the second element is called the image of the first element. If we get ordered pair, for example x comma y, and we say that this is first element, this is second element, right? And this second element is called the image of the first element. So y is the image of x. If you have 1 comma 2 and 2 is the image of the element 1, the second element is called the image of the first element. Okay, so the next definition is domain. Domain means the set of all first element of the ordered pair. If we have ordered pair x comma y, the set of all first element is known as domain. Okay, similarly range. Range means the set of all second element of the ordered pair. The set of all first element of the ordered pair is known as domain. The set of all second element of the ordered pair is known as what? Range. Understand? So the next is the whole set B is called the codomain of the relation. If R is a relation from A to B, so this is codomain. The whole set B is called the codomain. So if we get ordered pair in that, the set of all first element is known as domain, the set of all second element is known as range, and if a relation R is a relation from A to B and the whole set B is known as codomain of the relation R. Okay, I will give one example, then you clearly understand the definition. So I consider a set A as 1 comma 2. Okay, and I consider another set B as 1 comma 3 comma 4. So both are non-empty. Understand? So what is the Cartesian product of A and B? So what are the Cartesian product? So 1 comma 1, 1 comma 3, 1 comma 4, 2 comma 1, 2 comma 3, and 2 comma 4. So this is Cartesian product of A and B. We already know that, right? But relation means I define one relation R as it is a set of all ordered pair as x comma y such that x is less than y. I define a relation R as it is a set of all ordered pair x comma y such that, so this is the definition, x must be less than y. Here x is the first element of this ordered pair and y is the second are going to solve some more problems. Then you clearly understand the concept. Okay. And the first problem is, let a is equal to 1, 2, 3, etc. up to 14 and define a relation. Define a relation from A to A. Define a relation from A to A by r is equal to x comma y such that 3x minus y is equal to 0 where x comma y belongs to A. So write its domain, range and codomain. Find domain, range and also codomain. So this is the problem. Here they given that let A is equal to, they given the set A from 1, 2, 3 up to 14 and define a relation from A to A. So then it is a relation from A to A means it is a subset of A cross A. Here they give only one set and the relation is defined from A to A itself. Okay, and relation is defined by, it is a set of all ordered pair x comma y such that, so this is the condition, 3x minus y is equal to 0 where x, y belongs to A. All the elements x and y belongs to this set A. We have to find domain, range and codomain. Okay, so what is given relation? 3x minus y is equal to 0. So for this type of problem, first you have to consider this condition. Okay, so given what? Given 3x minus y is equal to 0, right? So simplify this one. So 3x, shift y to here, it becomes y, or it can be written as y is equal to 3x. So this is the relationship between the first element and the second element. Here x is the first element of this ordered pair, right? And y is the second element of this ordered pair, and this equation gives the relationship between the first element and the second element. We already know that both the elements x and y belongs to what? The set A. So what are the elements of the set? 1, 2, 3 up to 14, right? So x has possibilities of 1, 2, 3 etc. up to 14. So put the values. If x is equal to 1, so because 1 is the element of A, right? If x is equal to 1, then y becomes what? 3 into x means y is equal to 3 into 1, that is equal to 3. So then what is the ordered pair? If x is equal to 1, what is the value of y? 3. So the ordered pair is 1, 3 for x is equal to 1. Similarly, if x is equal to 2, right? If x is equal to 2, y becomes what? 3 into 2. 3 2s are 6. Then the ordered pair becomes, if x is 2, we get the value of y as 6. 2, 6. Similarly, if x is equal to 3, what is the value of y? 3 into 3. 3 3s are 9. Then what is the ordered pair? If x is 3, 14. But if you put x as 5, 3 into 5 becomes 15. The value of y becomes 15. We know that both x and y belongs to the set A only. But the elements of the set A stop at 14 only. 15 does not belong to this set. So that's why I stop here. Understand? So then what is the relation we get? What are the elements of the relation? So first one is 1, 3. Right? The second one is 2, 6. The next one is 3, 9. And the last one is 4, 12. This is the relation for this defined relation. Understand? They ask you to find domain. What is domain? Domain means set of all first elements of the ordered pair. Right? So what are the first elements of this ordered pair? So 1, 2, 3, 4. Right? So this is the domain. 1, 2, 3, 4. This is the domain for this relation. Okay, the next one is range. So what is the definition of range? Range means set of all second element of the ordered pair. What are the second elements? 3, 6, 9, 12. Right? So 3, 6, 9, 12. This is the range of this relation R. If the elements repeat twice or thrice, you have to write only once because inside repetition is not allowed. Understand? So also we have to find codomain. So codomain means what? The whole set B. So here we don't have B. It is a relation from A to A itself. So here the second set is A, right? Because it is a cross Cartesian product of A to A itself. So therefore codomain is equal to what? The set A itself. So we have, this is the codomain. Here it is a relation from A to itself only. So that's why the codomain is also the set A itself. Or it is equal to what? 1, 2, 3, up to 14. This is the domain, range and codomain for this relation. Understand? So we move on to the next problem. So the next problem is define a relation or define a relation R on the set n of natural numbers, on the set n of natural numbers by. So define a relation on the set n of natural numbers by R is equal to set of all ordered pair x comma y such that y is equal to what? X plus y, and also x is a natural number. X is a natural number less than 4, and also x comma y belongs to n. So write the relation R in roster form, and also find domain and range of the relation. This is the question. So define the relation R on the set n. N means set of all natural numbers by. So this is the relation. R is equal to what? Set of all ordered pair x comma y such that y is equal to what? X plus y. Okay. And they also tell that x is a natural number less than 4. X is a natural number less than 4, and both the elements x and y must be belongs to what? N. So we have to write the relation R in a The possible for x is 1, 2, 3. Less than 4 means 4 does not include. So these are all the possibilities for the value of x. So given what? So condition. What is the condition given? Y is equal to x plus 5. We know the possible values of x. Put these values, then you will get the values of y. So what is the first one? Y is equal to, first element is, first possibility is 1. If x is equal to 1, 1 plus 5 is equal to 6. So the ordered pair becomes what? 1 comma 6. If x is equal to 1, y becomes 6. Why? Because they given the condition y is equal to x plus 5. What is the possibilities of x? X is a natural number less than 4 means 1, 2, 3. If we put x as 1, we get 6. Similarly, this is for x is equal to 1. If x is equal to 2, y is equal to 2 plus 5, right? So it becomes 7. So ordered pair becomes 2 comma 7, right? So if x is equal to 3, y becomes 3 plus 5 is equal to what? 8. So the ordered pair is 3 comma 8. So if we cannot take x is equal to 4, why? Because they said that x is a natural number less than 4. So we have to stop here only. So what is the relation then? So what are the elements of the relation? 1 comma 6, 2 comma 7 and 3 comma 8. This is the relation. So they also tell that write the relation R in roster form. So roster form is R is a relation. So what are the ordered pairs? If x comma x plus 5, because they given that it is a ordered pair x comma y, right? So x write as it is, y means what? X plus 5. So the ordered pair becomes x comma x plus 5 and x less than 4, because x is a natural number less than 4. So this is the condition for x less than 4. And also another condition is xy belongs to set of all natural number. This is the roster representation of the relation. So the next we have to find domain and range. So very simple. What is the domain here? Domain means set of all first element. What are the first elements? 1, 2, 3, right? So 1 comma 2 comma 3. This is the domain. And range. What is the range? Range is equal to second element. Set of all second element, that is 6, 7, 8. So 6 comma 7 comma 8. This is the range for this relation. Understand? So we move on to the next problem. So these are all very simple problems. First you have to write the relation. So then clearly, easily you can write the domain and range. Okay. So the next problem is, if A is equal to 1 comma 2 comma 3 comma 5 and the set B is equal to 4 comma 6 comma 9, and define a relation. Define a relation R from A to B. So R is a relation from A to B defined by R is equal to set of all ordered pair x comma y such that the difference between x and y, the difference between x and y is odd, and also x belongs to A and y belongs to B. So then write its domain and also the range. Okay, observe that here they give two sets, A as 1, 2, 3, 5 and B as 4, 6, 9, and here it is a relation from A to B. Okay, the relation is defined as it is a set of all ordered pair x comma y, and the condition is the difference between x and y is odd. even is equal to, we get again an even number. So for example, take any even number 8 minus, take another even number, for example 4. So the difference of 8 minus 4 is 4. Again we get even number. Similarly, odd number minus odd number, again we get even number also. Because you can take any odd number, for example 7 minus another odd number 3. So difference of 7 minus 3 is equal to what? We get even number. But here the condition is the difference between the two elements x and y must be what? Odd. So the only possibility is we have to take even minus odd or odd minus even. Then only we get odd. If we take even minus two even numbers, we get the difference between the difference of two even numbers is again even. If we take any two odd numbers, we get again an even number. But here the condition that the difference must be odd, right? So for that we have to consider one even number and another one is odd number. Okay. So I hope you all of you understand this one. So then I write this relation as, so R is equal to, so x, first element x belongs to A, y belongs to B. If I take 1, since it is an odd number, it must be evens, right? So y belongs to B. So if I take 1, so we can take 4, or if for 1 we can take 6. Because the difference between difference between 1 and 4 is what? 3. It is an odd number. Similarly, difference between 1 and 6 is 5. It is also an odd number. If I take 1 comma 9, so difference between 1 and 9 is what? 8. It is even. So this does not belong to this relation. Understand? So for 1 comma 4, 1 comma 6. So if I take 2, since it is an even number, so here we have to take an odd number, because if you take 2 comma 4, so 2 minus 4 is 2, we get even number. Okay, so for 2, for even number we have to take odd number, that is 9. So difference between 9 and 2 is what? 7. It is an odd number. Similarly, for 3, if I take 3, since it is an odd number, we have to take even, that is either 4 or 3 comma 6. 4 minus 3 is 1, or again 6 minus 3 is 3. Again it is an odd number. For 5, since it is an odd number, we have to take an even number, right? 4 comma 6. 4, 5 comma 6. So 5 minus 4 is 1. It is an odd. 5 minus 6, again it is a 1. It is also an odd number. If I take 5 comma 9, 9 minus 5 is 4. It is an even number. So that does not belong to this relation. Understand? So this is the relation for this one. Okay. So we have to find the domain and range. Domain. What is the domain? Set of all first elements. Here we have 1, 1, 2, 3, 3, 5, 5. Repetition is not allowed. Therefore, what are the elements? 1, 2, 3, 5. Write all the first element of this ordered pair only once. Then what is the range? Range is set of all second element. What are the second elements? 4, 6, 9, 4, 6, 4, 6. So 4, 6, 9. This is the range for this relation. Understand? I hope you